Hello, everyone, and welcome to Bengaluru ACM SIGGRAPH first talk by Thomas. So we are very excited about launching our chapter, and I would like to take a couple of minutes and give some insights about what is Bengaluru ACM SIGGRAPH chapter. So Bengaluru ACM SIGGRAPH chapter is a volunteer-driven, and it is run by local professionals for the professionals. Uh, we also include students, so we work for students as well. And our chapter hosts events for the computer graphics community, and we are very particular about inclusion, diversity, including women in CG and tech. So if anyone wants to be part of the chapter or wanted to become like member, please reach out to us. You are always welcome. And to get more information on this, you can certainly visit our website or drop us an email on our chapter's email ID. So I would like to introduce our ACM SIGGRAPH Bengaluru chapter leadership team. We have Shiben, who is our secretary, and we have Vivek Reddy, who is the membership chair and treasurer, and Anand Sai is the vice chair. And we have many board members, but again, we haven't yet assigned the roles, and very soon we'll be assigning certain roles, and you might see some of them would be like kind of a advisor or a webmaster, or they might play different roles. So I will quickly call out their names and introduce them. Adishayan, Shivon, Meghana, Sriram, GL Kumar, and Hari Krishnan. Uh, at the moment, we don't have a couple of people added in this list, so I would like to take this opportunity to recognize them. Gurleen Singh and Balaji. Uh, like I said, we are a non-profit volunteer organization, and it takes a lot of time and effort for us to put this chapter together. And each and every event would need us to put in a lot of time and thought into it. We couldn't have done anything of this without help of all these volunteers. So I would like to convey thanks to them for all the support they have been giving. And how to join Bengaluru ACM SIGGRAPH chapter. So, like I mentioned, we are offering professional and student memberships. If you are interested in getting a membership, please do visit our website. And our membership chair, Vivek, and the committee has decided to make this membership for free, offer the membership for free till March 31st next year. So, but there is a catch. We only would offer memberships with at least a couple of referrals, which means that if you want to apply for a membership, you should know at least a couple of Bengaluru ACM SIGGRAPH chapter members, and you have to file an application. We will be reviewing the application and offer memberships to the appropriate members. So we'll soon roll out on the chapter members' benefits, so that you can also understand what kind of benefits and opportunities and the networking this particular membership would open up to. So SIGGRAPH 2021 is happening as we are speaking, and it's going to start the actual conference on 9th of August, and it will go till 13th. And there is an exhibition happening still from 10th August to 12th August. Please do participate in SIGGRAPH 2021. It will open up a lot of great opportunities for you. And we also have SIGGRAPH Asia happening in Tokyo this year. It's happening in the month of December between 14 to 17. Apart from this, SIGGRAPH Asia 2021 is accepting submissions for Computer Animation Festival. If you have a great short film, if you have visualizations or commercials or game cinematics, or any other animation or like computer generated content, please feel free to submit to Computer Animation Festival. And the deadline is on August 15th, 2021, which is in a couple of weeks from now. So please, you can take a note of this website, or you can follow us on social media, so that you can stay up to date with all our like information and the future events. Please like us and follow us on social media on Facebook, LinkedIn, Twitter, and Instagram. I'm sure you would get not only the insights about the Bengaluru chapter events and updates, but also some great updates regarding computer graphics and the future. So we just had a launch, and I just wanted to let you know that we have these dignitaries who did the honor of doing the launch some time ago. Without any further delay, I would like to invite Thomas and give an introduction and do the honor of doing the talk. Welcome, Thomas. Floor is yours.
Thank you, Shiva. Thank you so much, ACM SIGGRAPH Bengaluru chapter, for having me to give a talk. I will just share the screen and let's see whether that will work. I hope it's gonna be smooth and without any pain. I hope you can see my screen.
Yes, Thomas, we can see your screen.
Excellent. Thank you so much. All right. So I will be talking about computer graphics and interactive techniques as life inspiration. So I'm gonna tell you some stories from my life, but as well some of the projects that we did with my teams across my professional career that was connecting variety of different fields, including computer graphics, visualization, and computational science. So for those who don't know me, I was SIGGRAPH Asia 2019 conference chair, and I'm like a SIGGRAPH veteran. So I've been volunteering for SIGGRAPH for many years in different forms. So chair of several different committees, was as well a juror, as well author of the papers, submissions, and so on. So have quite good experience. So if any of you are interested in submitting something to SIGGRAPH, feel free to contact me and connect with me. I'll be able to give you advice as well on that. In my professional life, I have two positions. So one position is director of the Expanded Perception Interaction Center, Epicenter, which is like located at University of New South Wales. And this is university. And I'm gonna tell you a few words about the Epicenter because it's a very special place. I'm also team leader in visual analytics at CSIRO Data61, which is our national science agency, and do a variety of different things, including human AI interactions, visual analytics, hybrid analytics, and a bunch of different projects that some of the examples I will show you on this talk. I'm as well like a deputy director of Arrive Network and adjunct professor at UniSA. And Arrive Network, I should actually mention that because that's perhaps like the largest VR lab now in the world. If we connect all different universities together and people from different universities that have labs, we connected that to a network, which is network in Australia and New Zealand. So you can have a list of the universities on this picture. You see my Epicenter team. The photo was done in 2019, so it's quite old. I wanted to refresh that, but unfortunately, COVID disallows us to be back to the office for time being. All right, so start with my adventure. So I was very good in sports, and I was very good in promising actually in sports. And then my parents bought me a computer, and it was Commodore C64. So I stopped doing a bit of sports, unfortunately, for time being. But of course, I came back to that, and I was trying to learn a bit about the computers themselves. So you can see my first computer was Commodore C64. Some of you recognize that, and that's me sitting and coding and doing a bit of assembly x86. So I started basically like with Commodore C64, but then I transitioned to PC platform. And on PC platform, I really wanted to know a bit more about how to program computers from the bottom up. So I was thinking that those days that the best way perhaps would be to start with programming computer viruses because you can know the platforms very, very well. So I started doing computer viruses and I coded a couple of them. They were harmless, but it allowed me to know the system very, very well. And at one point I was very guilty. So I was saying, like, I spent, half a year doing assembly and I'm doing computer viruses. It doesn't make sense. Let's do something that matters. And then I switched to computer graphics. So that's where everything started. And in Europe, because I'm from Europe, I'm from Poland originally, spent half of my life there and half of my life in Australia, in Sydney. In Europe, we have something called demoscene, which is underground computer art stream, which connects people together that are using computers to do art in real time. So using mathematics and synchronizing with music, and basically, you're getting very beautiful presentations that are very inspirational, and you push the machines to the limits. So basically, like, I discover demoscene on Amiga and PC. I become swapper, so it was before internet, so we didn't have like proper connections everywhere. So we're swapping floppy disks, putting them in the envelope, and sending that off to different people across the globe. And my function in my demoscene group was coder and as well swapper. And this is like one of the party I organized in 1996. We called Rio. And the logo was kangaroo for some reasons. Maybe I had a feeling that I will end up in Australia at one point. I don't know. And this is like a snapshot from the copy party. So like lots of people with the computer sitting and coding and doing competitions, like really like a hackathon on steroids and stuff like that. So I already mentioned the demoscene was like underground art, and it was really born in underground, becoming now UNESCO recognized as an art stream properly from last year, which is very, very good to see because this is real art. And demos are the product of extreme programming and self-expression. So demoscenes are really, really crazy people like us in graphics that are pushing machines to the limits, but using mathematics mainly to do stuff in real-time graphics, which is great. Demoscene competitions, actually, like, demoscene is about limitations. So limitations are driving creativity. And demoscene, if you go to the event, there are a couple of different competitions, and competitions are basically based on limitations. So you could be limited by, for instance, executable size. So you perhaps, maybe some of you know, it's like 4K limitation, 64K, or demo, or maybe floppy size disk. And you had to actually fit your bytes count under that certain amount of bytes you are allowed to put in the competition. And then basically you're being judged by the people who are coming to the demoscene, and eventually, if you're good enough, you can win the competition and get, like, really good fame. So this is like kind of second kind of life that I was having when I was like really in high school and later at the university, is just trying to go there because it was super inspirational and so on. And I was doing that all in Poland. Why in Poland? Because like if you go to train, you can see like everybody does C++ in train. So you can see the studying C++ very, very hard. It's just a bit of joke, but that's true. Like that photo many years ago, I was very, very impressed by that. And everything what we were doing those days was assembly, because C++ and C were like very, very slow. The compilers weren't very optimized. They were not generating like the most efficient code they could. So we had to go to the very low level to actually like push machines to the limits. And this is example of one of my demos. So that was done in pure assembly. So for those who are interested, you can watch it later on. But that's all I put the source code. So you can see like we did have a bit of problems with programming into higher level languages because they were too slow. So all the graphics from the beginning to the end was done by assembly instructions. And we didn't have also like access to like wonderful software like Maya or 3D Studio Max those days. So we're doing basically like the word generation by writing the numbers. So you can see the definition of the scene is actually on the right-hand side here. So we define different kind of coordinate systems. And then basically you build the whole universe with small triangles. And I was having like the sheet of paper when I was calculating all these rotations on hand, so that I have the proper value that I put in the code that can be compiled and seen in 3D space. And my life really became for computer graphics. So that was like, I discovered this as my passion and was driving me. There wasn't internet in Europe those days. It was like 1994, 1995. Only people who were at the university had early access. I was just perhaps a bit too young to have that. Funny to say that because I'm not young anymore, kind of. And we basically like try to discover different effects and different ways of doing computer graphics by experimenting. Experimentation is very important in graphics, as you know. Whether you're doing, like academic paper, whether you're doing production grade software or rendering, you have to experiment always. So we had to really discover lots of effects ourselves. So this was like one of my font shading, the first ones that I did in 1995, I think. and it was done using environmental mapping, and we didn't know really how to do it. So it was like discovery like vector normals, lots of, I can explain the algorithms, but I don't think we have time for it. I wanted to show lots of examples, maybe later on, but it was really fun to discover stuff really step by step from scratch. So basically demo scene was something like what Steve Jobs said in the past. If you are working on something exciting that you really care about, you don't have to be pushed, the vision pulls you. And I strongly believe in this sentence, because this is basically how my life was going throughout, like using the passion to basically drive the directions when I was going. And at one point I discovered CD, SIGGRAPH CD, and I was shocked because I could discover all the problems, solutions to the problems I had those days, like out of the box, bang, and you have solution and you know what to go. So since then, it was my dream always to be part of SIGGRAPH. I wasn't coming from very rich family, so I was just saying, yeah, perhaps it will never happen. And somehow it happened in the way that it was, that I was able at one point to go to SIGGRAPH Asia 2009, where I was already in Australia after my PhD in Japan. And I was hooked completely. So SIGGRAPH is basically like demo scene. That's why I was talking about demo scene, because SIGGRAPH is about passion. It's about community. It's about connecting us together through computer graphics and interactive techniques. And it's like very inclusive community. So you can actually queue for coffee when we will be meeting face to face in the future. And then you can meet people like from a variety of different studios or academics and so on. And like wonderful people become your friends forever. So like me and Shiva will become friends forever. And I'm very, very proud that this SIGGRAPH chapter is now in Belgrade. So now we do have like as well, like lots of volunteering stuff you could do. There was always like the barrier of entry per se, but it's very, very easy when you start talking to people and connect with people. Suddenly everything becomes very easy and you starting being part of the community. So I encourage everybody who is willing to put themselves and serve as a community member for ACM SIGGRAPH, become not only chapter member, but as well go a bit globally. Just global connections give actually this chapter to, this kind of, push that your chapter can be well known everywhere. And this is what we want to achieve, because we have a goal with this chapter that I will say you at the very, very end of this talk. And, like SIGGRAPH sometimes, like is full of surprises as well. So I met my wife at SIGGRAPH as well time ago. So this is June Kim, and she's doing lots of things in computer graphics as well. And she's lecturer at the university here, UNSW. And I'm basically showing her as well. So you remember the face, because she's the chair of SIGGRAPH Asia 2023. That will be in Sydney, that you're all welcome to come and join us here in Australia. And if you do, please make sure you say hello to me or contact me before, so we can talk about some of the goodies that will be coming as a part of that. And I should as well acknowledge my parents that allowed me to put pixels art and demo scene. Even though they were thinking that I'm playing games, I was just saying, no, I'm just doing assembly to know how to draw the pixels on the screen. Anyway, now coming back to a couple of examples from my professional life. So I have two teams, CSIRO and Epicenter. And basically combinations of those teams are working on many different problems. So we solve problems, complex problems using visualization, computer graphics, modern computational platforms. And we build interdisciplinary tools and also building a bit of community practice here in Australia and also like globally, connecting variety of different fields. And for me, computer graphics is always very, very closely linked with visualization, which is like a sister kind of like area of research, because computer graphics is always the building block. And that's what I love the most, actually, like going to the lowest level. Coming back to my demos in background with, assembly, when we build stuff from the small blocks, this is the same with computer graphics and visualization. So I'm going to show you a couple of different examples how we use visualization in my professional life and across the groups. And everything, of course, again starts with pixel. So if you know how to draw a pixel, you can actually build beautiful artworks. And if you know how to build a beautiful artworks, you can apply mathematics to derive different, like photorealistic ray tracing, images, photography. You can use computer vision elements and so on. So this is basically reflecting that. And basically the future is now. So the stuff you've seen in Avatar, for instance, like a couple of years ago, or other movies like Minority Report, all these user interfaces and all these interactions are possible today, which is very, very exciting. So basically, like we do have lots of devices, lots of techniques that we could actually replicate some of these things that were actually perhaps mimicked those days, but today we could do it almost in the same way in real time on real data sets, like using building digital twins, for instance, of cities and so on. I will show you some examples of that. So we are really transitioning into augmented age. So I like to call it like that, because we become really connected with digital technologies, and this is not going away. So I think we did lots of research in VR that, in my opinion, is just transition, and we're gonna be having augmented reality everywhere, and you're gonna be connected to some kind of AI-driven thing. So connecting visualization, simulations, and AI will be driving our daily life. So if, let's say, you'll be walking, to get the train, you'll be having, different pathways showing you how to get to the train. And when you'll be passing different stores, you'll have different analytics engines giving you information about the products in the store. So you could jump in or buy it online, or just click and automate your life, really. So extend our capabilities as human beings and do lots of simulations. So this is an example of how powerful simulation can be. So this is basically how easy you can cheat the human brain. So you have a guy who's sitting on the platform with VR goggles, and you're just sliding on the sliding platform, and it's like you can really see how he reacts, which is basically fantastic. So that's what I always say. Whether you're talking about VR simulations or whether you're talking about simulation of real phenomena, like for instance fluids or ocean simulations, the simulations is very powerful and plays very important role that often requires visualization and ultimately as well computer graphics being in the pipeline. So mentioned that already. You can do lots of these things that was from the movies, so Minority Report, and some of the movies you can perhaps guess very, very easily. I hope all of you've seen most of these movies anyway. If not, I strongly encourage you to see, because this is classics of computer graphics, and that's what's possible today, as I mentioned. And I show you a couple of examples from my professional life. So I was working a bit in the past in CSIRO's mining exploration divisions, where we're looking at different aspects of sensors. And sensors are very important because they give us information about a variety of different things, including, for instance, weather, temperature, humidity. They can monitor and assist operations and automation, right? And then basically, if you attach variety of different sensors to variety of different, for instance, mining equipment. So this stuff you're seeing here, it's called underground shearer. So it's a device, or it's a piece of hardware that goes under the ground, rotates this big drum, and basically shears the layers of coal. And that's basically how you get coal out of the underground mines. The underground, you don't have GPS, right? So how do you do geolocation? So you use basically sensor called INS, inertial navigation sensor, that gives you acceleration. And if you integrate accelerations, you're getting the positions of the underground shearer, for instance. So this is an example of that when you have this very old computer graphics. It was done in Java 3D very, very long time ago. So don't blame me for the quality, but it represented the basically situations in the mine. So this is basically a mine that was teleoperated 3,000 kilometers away from the operating room. And you could see basically power supports and underground shearer. So the rotation of the arms and everything else, parameters were actually directly streamed from the sensors in real time. So this is kind of digital twin, like people talking today, right? Then we didn't call them digital twin, but today everything, whatever people do like that, they call it digital twin, which is basically perhaps the way how it is. So as an evolution of that, we're just looking as well in teleoperating different mining scenarios. So this is basically as you know, Australia has lots of great resources, natural resources, and one of them is iron. And basically there is iron kind of like a mining in Tampia, Western Australia. And basically they get the stones, they smash the stones, and the stones are being smashed and being put in the hatches of the bulk carriers, which is coming to the port. So basically what we tried to do in this particular project was to remove operators from the ship decks and move them to the control room which was located 2-3 kilometers away, and put them in air-conditioned room rather than having them in the 45 degrees heat. So I was doing it those days as well, like a bit of like 360 degrees stitching of the panorama. So that was before the mainstream 360 degrees. We did lots of innovations in that space. We tried to publish that, but because project was funded by industry didn't approve us to publish some of the great experimentations we were doing at SIGGRAPH. Unfortunately, those days it was 2009, and lots of stuff was very, very innovative. So we could actually like map the whole 360 degrees field of view, and then do augmentations of the point clouds, and do as well like augmentation of like, let's say, AR and computer vision techniques in real time, so you could detect different variety of things from the imaging only. So basically what we did, we as well had like a built visualization system. So we had like the Ladybug camera that was giving you images. We were stitching them together live using OpenGL, and then putting them on the hemispherical dome in visualization mode, so you could feel being like one-to-one, not being here on the real hardware. You could actually be in the front of the room, in the front of the dome, and you could feel like it was scale one-to-one. It was very, very powerful. So a bunch of different AR techniques we used to detect the hatches, but as well detect the I will just show you in a second as well. So this was like the operating room. So instead of person being in the 45 degrees heat, he was sitting in the front of the computer and having a bunch of joysticks that are operating the whole mining equipment. Very, very powerful. And then the whole system was integrating different things together. So you had like INS sensors and laser scanners, and you could basically build digital twin in real time. And it was done in 2009, 2010, so very long time ago. But at those days, we were using OpenGL, I think 2.1 or something like that for driving that. But when you have basically, you know, like the laser scanner going through the ship decks, it was scanning, you know, like tonnage of the hatches, so you could automatically update the icons. So it's a bit of like kind of automation built in, so a bit of AI processing as well. So very, very spectacular those days, and the industry that we are building that for, they love actually this kind of things, and perhaps would be still very useful today. And I hope they still use it today. So now we're going to Epicenter. So this is a bit of stuff that Epicenter, I'm gonna show you a couple of different projects and cross sections. So Epicenter stands for Expanded Perception Interaction Center. That's the center that sits at UNSW at the university. And Shiva, when he was visiting Sydney, he visited as well Epicenter, so he can tell you his impression later on after I finish this talk. We do a variety of different topics as per se. You can have a list of some of them, different areas. So if any of you are interested in international collaborations with Australia, feel free to contact me. If you work in any of these fields, like visual analytics, high performance VIS, VSIM and AI, of course, human in the loop HCA research, feel free to contact me. I know there are some, you know, like government grants between Australia and India. Maybe there is like some way of connecting dots. So you could visit our labs and vice versa. Some of my staff can visit you, and we can build some stuff together. So the lab has 5 different sub-labs. So we do have like Excel lab, traditional like VR, AR devices, you know, a bit of VG, leap motion, 3D mice, and so on. We do have computer graphics lab, which is like 160 cylindrical screen. So it's like very large screen fitting whole room. It's driven using 2 projectors and just 1 PC, which is very, very easy for students to actually take care of. And as well, we have like motion tracking system. So OptiTrack, 16 infrared camera, market-based tracking system. And basically we call it kind of eyewall. Then we have digital twins lab, so we have like walking platform, so you could simulate walking in VR on the platform. Not sure whether I have some photos on this presentation, so you can see later on. And then EPICenter is absolutely our #1 system. So currently EPICenter is, as perhaps some of you know, the cave systems. So EPICenter is custom-made cave system, which is 360 degrees cylindrical screen. It uses 56 screens, and we have 28 nodes driving the visualization. And currently, it constitutes almost 120 million pixels in 3D. And we say that perhaps it's the highest resolution virtual reality cylindrical screen in the world. which is very, very spectacular. And when Shiva was visiting Epicenter in 2019, we were just traveling together to Hampi, because like we really like always start our tours for people with Hampi, with wonderful panoramas from Hampi from different areas, and it's very spectacularly looking in our VR space. And compared to traditional VR, when you have the goggles, it's 60 times in resolution, so you can imagine the sharpness of the image and so on. We do have a hemispherical dome, so this image is done in the dome, and we use it for a variety of different user visualizations and interactions with the systems, and showing different animations to explain very complex sciences and stuff like that. This is a bit of like showing you how the screens are basically built. So it's 56 of them. Behind every screen, you have like a projector, and projector has a bunch of different, like there's as well sets of different mirrors and so on. And then we have very high, accurately calibrated edge to edge, pixel to pixel, and as well colors across all the screens. So you have zero bezels. Of course, you can feel a bit of your angles between screens, but when you're in 3D, you don't see that anymore. We do have as well like GPU cluster, so doing a bit of GPU computing. You could accelerate your computations, but as well the traditions we have when you have a birthday and you are in Epicenter, you will be tasked to bring a cake. And this is example where don't tell anyone how you can use supercomputers. This is one of my postdocs. He brought like a frozen cake, and we had coffee time like 1 hour after. So basically, like we needed to defrost the cake very, very quickly. So we put GPU compute, and basically like outside of the GPUs, and the cake was ready in 1 hour. So this is the way how you can use GPUs. Anyway, so those are a couple of examples. I hope you can see animation smoothly. This is always very tricky when we do presentations over the Zoom, but this is the highest resolution fragment shader in the world, I always say, because it's using ray matching technique for simulating the ocean. And this is some of the stuff we teach our computer graphics students, how you could do it using mathematics in real time. So this particular one is using 28 GPUs to drive the simulation, and it runs 120 frames per second, and it's interactive. As well, for those who are like geeks in mathematics, you could go into World of Fractal, and basically the way how it works, you shoot the ray to every single pixel on the screen. It's like typical ray tracing, but it's a bit simpler. It's called ray matching, when you actually ray match to the solutions of the equations, and once you're there, then you can get the value of the pixels in colors, and then draw like different 3D visualizations. Like this one is a fractal, just very simple equation, but gives you this wonderful kind of artificial world that you could perhaps remember from some of the movies as well. Then, of course, like lots of stuff this is perhaps very hard to see on slides, but it's very spectacular in the Epicenter. So it's point cloud, geometric reconstructions of the Parramatta site. It looks absolutely spectacular, and it's very, very sharp, because as I told you before, it's almost 120 million pixels in 3D that does the job already. And you can do it for a variety of different applications. So this one was used for art exhibition, but you could as well use it, for instance, if you work in AI and robotics, use this kind of point clouds to train the robots to work in this particular space, and do transfer learning to basically put them, like you don't need to do expensive experiments, just using AI for and computer visions and connections to through VR. This is one of our perhaps best examples how you can use the ultra high resolution screens. Often when people are coming to Epicenter, they ask, why do you need screen of that resolution? It's expensive and stuff like that, right? Yeah, it is, but you get some benefits. So in genomics, for instance, space, you have variety of different data points, and this is a whole chromosome map, and you can build like a viewer. You can put all the chromosome map. This is coming from the human cancer cells in the front of the people and scientists, and they can export the data as they wish. So, for instance, they can select a point, and they go inside, and it's basically like a microscope on data. You can imagine having 4 terabytes of genomics data set, and basically being able to browse it from the left to the right, inside and outside. On the top of it, which is very, very powerful. As you can see, this is Dominic, who is one of my staff, is wearing HoloLens. So HoloLens works very well with our cave. So you could actually combine the gestures and as well eye gaze for interacting with the whole system. And then you can do a variety of different things in VR systems like that, like collaborative visual analytics. It's much better than VR because we don't need to simulate people using avatars, right? So that's basically benefits we're getting. We can do projects such as, like interactions with different networks. So this is like a project we did on social media networks, businesses and users from the Yelp data set that was open. We built a massive network and we use very high performance graphics pipelines with GLTF, directly plugging into GPU memory and using shaders to visualize the network. So they run in very high resolution, but that's what they are very, very fast. So we can interrogate millions of points in real time. So it's running 120 million pixels in 3D. You can see directions and the flow of different nodes. So which node is going to which node, and then you can interrogate different data sets. So you can do clusters, you can do collapse, you can do as well, like zoom in, zoom out, of course, and change different layouts as you wish, all in real time. So this is actually like sitting in network analytics space. That's perhaps I could talk about this for 1 hour. But if you're interested and if you're attending SIGGRAPH 2021, we actually giving 2.5 hours course about this particular project. So please join SIGGRAPH and watch this course if you're interested. Now, I mentioned briefly like as well digital twins. Digital twins is, like very, very popular these days, but I just repeat, perhaps sitting within the industry 4.0. And it's basically digital twin is a virtual representations of a physical object or system. That's how SAP defined that. And it's basically, something that we actually do for years in computer graphics, right? Like SIGGRAPH and, all the VR stuff and trying to replicate the reality and connect to engineering systems. We're doing that for ages. But the industry is catching up now, and everybody is trying to jump on in this field. So this is basically like some of the examples of some of the simple digital twins we did within the university. So this is university campus, and that's using voxel visualization. So it's just photogrammetric reconstructions and as well, like scans. And then we're flying through. And this kind of use cases can be used, for instance, for navigation of, like you have new students coming to new university. They don't know where to go. So they can use basically digital twin to navigate through the space and stuff like that. Then you can imagine as well. So this project was, let me see what this will play. They should play. This project was called HoloCity. So it was using one variety of different holograms connected to different endpoints in the Sydney city. So what we have Oli, who was my PhD student, and he was basically like visualizing different readings from different sensors and different endpoints on the map of Sydney. So so you can put this above the table and you have like 5 people, for instance, looking at the same time at different transport data, for instance. So it's very, very powerful kind of way of visualizing data, but as well, it can be very useful for government decision makers, especially those who are doing city planning. And, for those who perhaps been to Sydney before, or you perhaps know, we have like sometimes like very, very not optimized roads and traffic is very big. So this is example when you have, road and you have like different peaks, and those peaks represent basically like the traffic congestions. So systems like this can be very useful for like, let's say New South Wales Transport, for instance, when they can actually look at this data and make decisions how to build the roads in a better way. Then you might have as well systems when you're building new metro, for instance. So that was another project where the company wanted to have a one-to-one representations of the metro station. So I won't mention the names, but the idea was when you build the metro station in the design phase, you want to see and simulate like the congestions of the people. That could be perhaps useful as well in COVID times. So tic-tacs are representing people coming out of the trains and they're traveling on the escalators. And then those people who are doing design of the metro stations, they can actually see the numbers that telling them whether they should change something in the overall design. So very, very powerful tool. We did also like a bit of like project with there was like a project with Indonesia where we're looking at the AR and how AR can be used to basically for emergency situations, like for instance, flooding was coming in. So we grabbed a bunch of different elements from the maps and basically did like geographical regions, map them to AR, and basically you could interact with the whole system in the real time. So you're seeing like the AR hologram hovering over the room. It's in the EPICenter, and then you can actually like zoom into different areas. So this is another example how you can use digital twinning and real-time computer graphics really to actually do imaging and very quick and optimized planning of the cities or emergency situation, that decision making. Very, very powerful tool for that. We did as well like digital twin of scientific equipment. So this is ASCAP, which is Australian Square Kilometre Array. In Australia, we do have like this system which sits in the outback. It's sets of antennas looking in the outer universe and scanning different radio frequencies. So it can be used, for instance, to detect different galaxies or maybe UFO. I don't know. But we're trying to do basically replication of the feelings, like you in VR, where you are like almost one-to-one in the environment when you're looking at sets of different antennas, as this one, and simulating as well like day and night plus star constellations. So this VR was built as a tool. It's not a game, and basically like I'm saying that because for instance like constellations of the stars are 100% correct as well. So like the locations on the sky, because they wanted to have the people who are working on particular projects in radio astronomy, they wanted to have very accurate representations of the star positions. So we could set up in the timer, I want to see the stars, let's say 50 years from now, how they're gonna be looking like. And then based on that, they can do a bit of, planning towards the future, what elements of the skies they wanted to scan with those antennas. And this is perhaps like one of my last examples, which is showing saving Jaguar. So how you can use VR, gaming, GPUs, and statistics and variety delivering good for the community as well. So that was a project that was done in Peru. So Peru has jungles, as you know, and there's like jaguars there, like the big cats. And there's like mining industry coming in and destroying the nature. So we assembled a team in collaborations with Peru from Australia. Several people went there, and they were looking at capturing 360 degrees environments using like variety of different cameras and sensors, and basically using that to elicit information from the VR. So if you are expert in VR, you don't need to travel to Peru anymore. You can basically look at 360 images and basically guess the certain parameters from the images, like, the presence of the jaguar. So we do have like a movie about it. I'll perhaps skip that one. You can watch it later if you're interested. And basically out of the images we had from Peru, variety of different VR use cases, but as well we did the paper that was showing using a bit of stats and maths based on expert elucidations about exactly that problem, like presence of jaguar in different locations, how they should be moving across the jungle, where they're moving through the jungle. So when the mining industry was coming, we could actually tell to the government, just don't allow them to do that because they will destroy the corridors for the jaguars, which is very important in the nature. So this is how we can do VR stuff for good. So this was my last example. So this was like variety of different examples and use cases from my life. Feel free to contact me if you're interested about any of them or collaborating with us. I wanted to say, like I followed my passion and somehow the stars were always aligning, even I was telling you about, for instance, not thinking in the past that I perhaps will never be able to go to SIGGRAPH. But, here we go. Experimentation is important, so that's important in professional life, but as well like when you're building chapter, like experiment with different ways of interactions with the community, and community is the key. And again, congratulations on SIGGRAPH chapters, of course. And one thing what I wanted to mention as well, and Shiva already said that there is SIGGRAPH 2021 happening shortly. So I guess some of you will be attending then, if not all of you. I encourage you to really go there because this year program is absolutely wonderful. And I should say as well that Shiva didn't mention that. He mentioned that the SIGGRAPH starts in like in more than a week time, but SIGGRAPH starts actually from Tuesday next week. So after this weekend, because the platform will be open for everybody to come and watch some of the pre-recorded sessions. However, the live and Q&A will be like starting from 9th, which will be like week after. And last but not the least, I wanted to encourage you as well to have a look at the program that I am chairing this year. So this is ACM SIGGRAPH 2021 Frontiers program. It's very, very special because we try to do it in a special way. So we have like a small subcommittee working and helping me to set it up properly. And we already run around 19 sessions. So if you go to SIGGRAPH, to this link, SIGGRAPH/program and Frontiers, you'll be able to see SIGGRAPH Frontiers interactions, and Frontiers interactions were recordings of different sessions that were happening before SIGGRAPH, and they are fully open for community. So if you have like free weekend, you can watch all the recordings. So we have like course about deep learning. We have a bit of hands-on demos in coding. Yesterday we had like democratization of visual effects panel that was very, very good. It was Animal Logic folks and other companies, very, very engaging as well. And I'm saying this is free of charge. You can send it to your friends and colleagues, and you know they can watch it. During the conference, we're gonna have two other programs of Frontiers. So one is talks. So for instance, we're gonna be having like a talk about the Mars landing and using computer vision to estimate the locations for the Mars rover, AR dilemmas, and as well we're gonna have workshops. And workshops are actually very, very very well done this year as well. So if you attend SIGGRAPH, just please check the Frontiers. If you don't attend, you can check interactions. They are online on YouTube. You can watch the videos. And last but not the least, again, congratulations to Bengaluru SIGGRAPH chapter. And again, I wanted to say that I really want to come to SIGGRAPH Asia and India. So this is perhaps something that will be and was my dream always when I was talking to Shiva always. This is something you guys can make it happen in India. And if you need any help, we're here to help and give advice and as well connect dots across a larger international community, because to put the bit in, you need that as well. So that's it from me. Thank you.
Thank you so much, Thomas. That was really wonderful insights, and it was a very great session. Thank you very much, and also thanks for all your well wishes and all the support you have been giving. So we have a few questions. Can we take some questions now, Thomas?
Absolutely, not a problem.
Thank you. First one is from Vikas Vishwanath. As a writer, director in films, how can I make the most out of my participation or association with SIGGRAPH?
Okay, good question. So as you know, SIGGRAPH is about computer graphics, emerging technologies all together, and allows you to actually learn from people. So the best way would be just to participate and ask the questions, ask and learn from other people. That's what I would say. And Shiva will agree with me, right? It's basically like that's what I love the most about SIGGRAPH. We basically learn from each other. And not only that, because once you attend some of the talks or panels or production sessions, you could actually go and speak to those people that are in productions that can help and drive perhaps your writing style or writing directions, that you can understand how to do it better. So I hope that answers your question. Shiva, you can add maybe something to that if you wish, because this is very general.
Yeah, and Vivek can add to it.
Yeah, I would like to add some more details for it.
Please do.
It's the exact SIGGRAPH is meant for creatives equally as much as for technical people. So the idea is we cannot make beautiful art without going through the technical requisites for any outcome or any product in this current world. So the idea is, even though coming from a writing background or a directing background, you can see how technology can help your vision come alive through these conferences, where you actually get to see, all right, for my next movie, maybe I can use these simulations from this research and actually use it for this kind of a world building exercise. Or maybe this is the kind of facial expression capture that's going to help for my content character creation. So be it anything, the technology that's being discussed here is the critical component for any creative. So which is why when I have been to like 8-9 SIGGRAPHs in my career, I see all the best creatives attending, best producers attending SIGGRAPH, even though they'll be silent and not really actually getting all the attention in the technical conference. They'll actually be listening and observing carefully. All right, this is the team, this is the technical team I need to work for my next project, kind of a thing. So it's actually a very collaborative effort. And like Thomas clearly mentioned, socializing and connecting with these people is critical, and making connections with the right teams, and hence being part of the community is going to help. So that's like an answer I want to give, like why SIGGRAPH is essential for a creative, like someone like you, Vikas.
100% agree. And I should actually add to that, don't be shy and just reach out. There are like a couple of programs you could always, let's say you have some problems in writing, you want to actually translate it and connect with digital technology you don't know, right? So you basically could propose a birds of a feather session and get people to help you to understand and maybe drive some of the vision. Because that's what SIGGRAPH is all about, helping each other. It's a great community. And I should say, actually, it's actually not only community, it's our family too, right? Because that's actually something I tell to my student, be careful, you're going to SIGGRAPH, it won't be your last time. It's gonna be first time, and you will be going until end of your life. That's how it is.
Totally, Thomas. I absolutely agree with you and Vivek. So just to add to that, because I'm just like you, I'm not a tech geek like Thomas or Vivek or Shiven. I'm more of a creative person or more of a production person. But again, it's all about networking. You might have a problem and you'll get to know that using some particular technology, you might be able to solve it, and you may be able to tell your better stories. So yeah, cool. So we'll move on to the next question. So next question is by Professor Vijay Natarajan. Can you comment on new data representations that are required for the digital twins? Any news data standards that are established? I can imagine that the well-established spatial structures may not be sufficient given the need to incorporate physics functionality and other attributes.
Yeah, so this is very, very good question, and this is like, of course, ongoing research. How you actually represent the universe. It's not only about geographical stuff, because often if you talk about digital twins, I'm not sure how it is in India, but in Australia, I've noticed if somebody talks about digital twins, they straight away think about maps. It's not only about maps, it's as well about the structures, buildings, different kind of, equipment that is driving that. So for instance, infrastructure like water, and connecting to that as well, like physical or computational part of that, of course. So there are, of course, a couple of standards, and especially in GIS space, there are like consortia that are working on standards. We're working on a couple of things, how we can actually create the standards, for instance, for connecting simulations, so like computational fluid dynamics through computer graphics, but as well using voxels of representing the universe. So this topic is actually like, we can talk about this forever. So maybe I just suggest, Professor, just let's take it offline, and maybe let's connect with each other. If you're in the same topics, maybe there is a way of collaborating in the future on those topics. 100%, because this is the way where the universe is going, and that's where actually, like the computational science, computer graphics can be in the middle, but it connects not only visualization and graphics, but as well simulations, AI, and so on. And definitely we need standards for that. So there's lots of works happening in the universe, but it's very, very complex at the moment.
Sure, Thomas, thank you. So I'll connect you with like Professor Vijay Natarajan, and we'll take it off.
Yeah, fantastic, thank you.
Thank you, Thomas. Next question is from Sai Krishna. Great projects and setups, Thomas. A question: how do you ensure the sustainability of so many devices in your lab when such technologies like VR is advancing so fast, and new upgraded headsets and equipment, GPUs, are being released every moment. How do you create a sustainable model in your research with the older headsets, like dispose them off or donate them off and upgrade to new ones? I started a similar lab at a smaller scale at university, Srishti Manipal University, and wondering what is the best way to put the older headsets and equipment.
Okay, yeah, this is very good question. So yeah, so we do have like, as you could see, we do have like 5 different labs and sub labs. Those different labs have different systems, and those different systems use different hardware on different level of, you know, like some of the GPUs are very old, some of them new, and so on. So one of the things that when we started building Epicenter, I had this in mind that we need to build a system that allows us to basically like run universal code that runs across all these devices. So for that reason, we developed something called high-end visualization system. So if you go to the website epicenter.matters.today, you can find the link to the whole system. So it's basically like give you transparency of building one VR system, let's say, and you can deploy it to any VR AR devices or cluster-based system. Because like if you're only on VR, it's very simple. You could use one PC. If you're developing stuff on cluster-based systems, like we have EPICenter, then you have 28 nodes. They need to be synchronized. It's more complex. So we try to build a system that's very transparent. High-end visualization system we develop is going to be open source. So feel free to contact me and I give you access to that so we could drive your lab and we can give you some use cases where you can straight away have some demos in your lab from us. And if you use and develop some stuff in your lab, we could actually exchange and maybe build these collaborations going forward. With the GPUs and upgrades, this is very tricky stuff, of course, especially with the bumps we have now in academia with COVID. So like if I want to upgrade my whole lab, it's gonna cost me a lot of money because I have lots of screens and computational powers and so on. With the devices and PCs, there's like the usual policy at the university, you know, like the hardware is getting out of life in 4 years, and then you can actually apply to replace the VR devices and stuff like that. And basically what we do, we usually give it back to IT, and they do like perhaps donate some of that, which is perhaps very good because it could be used at schools and so on. So just like, yeah, another way of perhaps, you know, like thinking how you can do those things sustainable. And unfortunately, technology, as you said, evolves very quickly. So we try through our framework actually to address the changes as we go in the framework. So when you use HEVs, you could basically, you know, like satisfy most of the current available platforms, and as well like it's going backwards, so you can drive them using, if they are like, you know, like in 15 years time, you'll be able to run on them as well. So again, feel free to contact me about that, and I can give you links so you can try our framework. Maybe that's something that would be useful for you and your lab as well. If you have any questions, just feel free to send me email or message, whichever way you.
Thank you, Thomas. So next question is by Ganesh Belgur. Thanks for the great talk and an amazing start to Bengaluru chapter. I'm interested in knowing your thoughts about the future of computer graphics outside the media and entertainment industry. Do you believe internet as we know it will change into metaverse eventually? Metaverse applications are believed to replace the browsers that use a traditional 2D interface.
Yeah, that's why I smart. I think this is tricky question, right? Now this is obviously where this stuff is going. We do have like we're seeing in the industry big move into metaverse. So like for instance, you can have a look what NVIDIA is building is absolutely amazing, and gonna be the future. So I think and well, if you're talking about the graphics, so believe that, you know, augmented reality will be everywhere as well, and you need to have like the infrastructure. So there is like one talk at Frontiers program I strongly encourage you to attend by Mark Peske. He recently wrote a book about AR as well, and he's talking about the metaverse and where these things are going. and I believe really in that we're building, like the metaverse applications outside of media and entertainment, especially the area of, like, for instance, immersive analytics is basically that's something that can link very closely to that in terms of understanding our universe in better way, I guess. So this is like another example of like topic we can talk for hours about, and again, I encourage you to look at the SIGGRAPH Frontiers program. Vivek, I think you want to add a few things to it.
Yeah, definitely.
Go for it.
Yeah, so about the outside scope from media and entertainment industry, I just wanted to give an example. There is a massive growing space industry in Bangalore right now. 8 or 10 companies have opened up in the last 1 year, and everybody are going for simulations. So there was a company called CSIRO, which was dedicated for aerospace engineering, and now it has come from movie industry. So what I'm trying to tell here is there is space industry, there is automobile industry, there are so many industries other than the movie industry that are corely dependent upon computer graphics. Like any screen you see with any pixel coming on board, then there is computer graphics over there, including your operating system. So the thing is, it is a very core area of subject for every industry. And that's why like we're planning to bring on board some space simulation people to talk about, hey, how are we using OpenVDB simulations for making the volumetric analysis of our flight simulations and everything. So yeah, there are so many other industries depend on it. And to add on metaverse, yes, Facebook announced recently about metaverse, and it's getting very serious now. But yeah, combination of IoT plus internet is what everyone is looking, physical plus digital. We'll see where it goes. We're all trying to predict as well. That's all.
Yeah. So yeah, this is very good. Yeah, I'm really looking forward to where Facebook will go. I think like Zuckerberg announced everything they putting bet on metaverse, right?
Yeah.
Which is interesting. And Mark Pesca in his talk at SIGGRAPH Frontiers, if you're gonna watch that as well, he's talking about kind of AR-based IoT, so how we can actually communicate and build the networks in completely new ways, and proposing a protocol for that. So I strongly encourage you again to look at that.
Yeah, Siva.
Cool. Thank you, Thomas. Thank you, Vivek. So next question is, how would academician or research, how would an academician get into research publications through SIGGRAPH, or how would SIGGRAPH would be helpful for academicians in research publications?
Okay, so perhaps there's like two sides of this question I can understand. So definitely, like if you're at SIGGRAPH and publications at SIGGRAPH, there are different programs have different levels. In general, SIGGRAPH itself is A-star conference in the rating, so it's the best of the best. If you can get published.
Sorry, Thomas, your audio is not being heard. No, not yet. Vivek, can you hear Thomas speak?
No, it's getting muted. But I can add a few points while Thomas fixes the audio on his side. So is it working, Thomas?
I think it's the Bluetooth probably.
Okay. So I can add a few points like how would it be helpful for academicians in research publication, right? So with SIGGRAPH, what happens is we'll be bringing the hardware companies, the software companies, and the problem statement itself, which is the creatives itself. So what happens from a research point of view is when you get to know the core problem statement in any industry is when you can actually go ahead and actually solve for it from the research point of view. So that's one point I wanted to add. Yeah, Thomas, you can go ahead.
Yeah, sorry, I lost my battery on my other headphones. That happens when you are connected too long. Yeah, I just wanted to say, like, encourage people to submit publications to SIGGRAPH because it's really like a core. In general, I think it's the 6th in computer science and across the fields, as per SIGGRAPH rating. So it's very, very highly rated. And as well, like technical track, what I would say, just observe and read how people are writing the papers and learn from it, and they maybe try to also like slowly go to maybe like easier programs at the beginning if you're starting your career, and start with like the programs that are not very, very heavily academically judged, like VR or AR or maybe e-tech and stuff like that. and then slowly transitions to like more core computer science, depending from which field you're actually coming, because you could publish as well in art streams. And this is again, like very big topic. So if you're interested in certain tracks, feel free to contact me as well. I'm happy to help you and guide you which programs and how. And you could usually, reach to the chairs of the programs. They can answer your questions if you're trying to publish as well. But attending SIGGRAPH will help you to understand the scope and how people are publishing the papers and publications. And there is also like this ACM digital library that you could actually look at and learn perhaps from it as well. I'm not sure whether Vivek, you mentioned all of that. Sorry, I didn't hear you because I was swapping the headphones. So sorry if I repeated some of the stuff you already said.
No, that was a good one, Thomas. Thank you.
No problems.
Yeah. So with this, we are done with all the questions for the talk. Thank you once again, Thomas, for taking your time and doing a wonderful presentation. Really appreciate on behalf of our committee and the audience. So
you're very welcome, and thank you for having me, Shiva and team.
Yeah, it was great, Thomas. We really appreciate all the aspects you touched on and all the different subjects it goes into. It really helps give a world view of what is this industry like, kind of a thing. So that was great.
Yeah, thank you.
Yeah. So yes, it is a virtual event. We are not able to really see each other. We are ending the talk here, but again, we would like to keep this webinar going on for some time. So if someone wants to